A quick note on Cavaliere's principle. So this principle says that effectively, if all of your cross sections have the same volume, then it doesn't matter if you shift any one of the cross sections around, the net volume is still the same. This is best illustrated using a stack of coins. So consider a stack of some number of coins, and then imagine you come by and just kind of move them all a little bit so that they are not directly on top of one another. They're all kind of skewed. Much like what you would do if you were stacking them yourself, they wouldn't be perfectly set on top of one another. So certainly this volume here is exactly the same as this volume here, even if our cross sections are skewed. So an extreme example of this, which is a common trick question that stumps a lot of people, is imagine that you have a right circular cylinder. Okay. And let's say that this height here is h and this radius is r. Okay. And then imagine that we apply this like shift or the shear to it. So let's say everything goes to something like this. Okay. So this doesn't look exactly the same, but let's go ahead and just say that this would be exactly the same. Okay, not a perfect artist. It's okay. So the only difference here is that we essentially took this line segment and we rotated it by some amount, theta, let's say. So I'm going to draw the original vertical line there, and we're just going to say that this shift here was some angle theta. So we know that the volume for this one is pi times the radius squared times the height. Now the question here is, what is the volume for this figure? So using Cavaliere's principle, we effectively are going to notice that the cross-sectional area for all of these circles is the same. The same as all of these cross-sections. So this figure has cross-sectional area that are all equal. This figure has cross-sectional areas that are all equal. And maybe my picture doesn't show it perfectly, but let me also say that this distance here is still h. So the same height, we just sort of shifted everything to the right. Well, using Cavaliere's principle, there's no work to show for this. It's just that idea. We have the same cross-sectional areas, and we still are moving that same amount h vertically. So the volumes are equal.